Hello everyone, today using my thermal camera and my 3D printer I'm going to show you yet another example of one of the most common bugs in all computer programming. And I've heated up the build plate of my 3D printer to it's currently at 83 degrees, it should be rising to about 90 right now. And you might notice that the sensor range of my thermal camera is frequently calibrating. It's automatically calibrating all the time. So usually the warmest object in the image should be orange or white, and the coldest object should be blue. And no matter what you're filming, if you're filming just one object or very similar objects, it automatically gets more sensitive, so that there's always both red and blue on the screen, and the sensor range adapts as soon as something really hot or something really cold is in the image, so that the full range of temperature can be displayed. And within this, now this is not really a damaging error or a big problem, but this happens with a tiny bit of delay, and somewhere in this programming where the data is where the sensor data is actually transformed into a visible image that is rendered onto the display, there's a typical buffer overflow bug, which is one of the most common bugs ever. I think I can demonstrate it for you. If I move the camera very quickly, because it's only a little bit of delay, so it has to be very quickly to show that bug. But if I move it quickly to bring the build plate into the image, sometimes a little piece of that build plate will be blue, which is definitely wrong, because that indicates it's the coldest thing in the image while it's actually the hottest thing in the image. And this is because of a simple buffer overflow. The sensor range of the actual sensor is quite great. It is relatively precise while having a large range. So it doesn't fit into your typical small microprocessor 16-bit or 8-bit variables, which are used to render the actual image, which is probably in 8-bit colors. So it only has 256 steps. So if you wanted to display 0 to 256 degrees, then you would have steps of 1 degree, not of 0.1 degree. So that range is adjusted, and since that happens with a little bit of delay, for a little while that range is bigger than it should be, and so variables bigger than the biggest possible value happen, which causes the actual processor to generate a number that basically goes around and comes out at the bottom again. So it is then the lowest possible number. This doesn't happen instantly all the time, because there is a little bit of free range above and below the minimum and maximum. There is a little safety margin there. And it's not really a big error, but this is one of the most common things that can go wrong in programming. It's one of the most common bugs. It happened in a program I worked on once, was easily resolved. If you watched Scott Manley's video about spaceflight blunders, it was together with, again, an inertial navigation unit, the reason why the first Ariane 5 crashed. It is one very common bug if you learn about big, well-known bugs or hacking attacks. It was back when Kerbal Space Program was all 32-bit. It was the reason why you couldn't go very far away from Kerbal, because then you'd cause this, which would theoretically cause your spacecraft to come back out at the other side, back into the solar system, but since that messed up the physics, the game just crashed. So this is overall one of the most common bugs, especially when working with small DII projects with small processors that are still 8-bit or 16-bit rather than 32-bit or 64-bit. And it's very, very often overlooked and just incredibly common. And here I've found yet another example of it that is not quite as catastrophic as an Ariane 5 rocket exploding. I hope you found this little bug example somewhat interesting, and as always, thanks for watching.